Hello, ladies and gentlemen, and welcome to our We Do portion of Lesson 24, where we're going to solve some word problems using fractions and decimal multiplication. Now, what I really want to stress to you is that to be proactive, stop the video from time to time and try it out as much as possible. Okay? Especially with these word problems. Because if I was there with you in class right now, and you were a little confused and you raise your hand and say, Mr. Philip, I'm not sure what to do. What's the very first thing I would say? I say, there's a couple things you certainly need to do before, and I know you can handle that. Right? That would be to read it, find the gist, write a sentence with a label. And those are ones you could do even before trying to understand fully the equation or the picture. Okay? So as we work, pause the video, right? Do as much as you can, then play it. Rewind it as many times as you need to. You can do it, and we can be successful. So let's get started. So as we work for lesson 24, we know that we have a reference sheet. You can even pause it at the 1 minute and 15-second mark here to check it out if needed. And we also, in our teach piece, talked about there's a couple of different ways that we can look at fractions and decimals. And if we have a fraction, we can make them into equivalent fractions with tens, hundreds, and thousands. Or if you are, the other strategy is that you can simply divide it. Remember that the numerator always goes underneath the house in our standard algorithm. All right. And you can certainly go back into that teach video to watch it a couple more times as I solve all of these. Now, I'm not going to do number 1 here on page 103. That is your exit ticket. Right? But I will go to the next page, and we're going to look at number 3 here. And as we work, please make sure again you can pause the video when needed. All right. And let's get started. Andre completed a 5-kilometer race in 13 minutes and 13.5 minutes. His sister's time was 1.5 times longer than his time. How long in minutes did it take his sister to run the race? Think about our RDW, or I sometimes say the RWD. So we read it, find the gist. It's all about racing. Let's find our details, right? Or even write our sentence. My sentence, no matter how I write it, is going to have a label of minutes. Okay, pause there for you to solve that. Right? And we want to know about his sister. So I might say his sister ran in blank minutes. And we'll abbreviate that there. So what are the details that we're going to need to solve that? Well, the 5 kilometers, the 5 doesn't really help us out. It doesn't matter how long the race is. It could be a marathon for all we really care about. But what we do care about is that Andre went and solved a race in 13.5 minutes. Sister's time was 1.5 times longer. So I'm going to include that times longer in there. That's even a hint word. Okay. So as we know, I like to draw some pictures. So I'm going to have Andre. He ran his race in 13 and 5/10 minutes. And sister, well, she ran in 13.5 minutes as well. But then she went a little bit longer. And we're not sure what that is at this point. We got to find that out. Right? But we do know it's 1.5 times longer. That times is a great key word. So we're going to do 13 and 5/10 times, right, multiply by 1 and 1/2. Okay? Now we got to think about what we can do to solve this. And we can turn 13 and 5/10 into a fraction, and I typically like to do that. Right? But I also see 1.5 is really quite small. Right? So I might even try that as well. Right? So pause the video, solve it one way, solve it both ways, see what you come up with. Right? I might, just to start, hopefully you're playing back the video right now, I'm going to multiply this by 1, and I know a half is 0.5, as we talked about up here, 0.5. Right? And we're going to multiply these. Well, I don't like those decimals there, so I'm going to multiply this by 10 and get rid of the decimal. 135. And I have my 1 and 5/10. I don't like that decimal there, so I'm going to get rid of it right now, and I'm going to have 15. And I'm going to multiply those. And as I multiply, I'm going to start with this 5 right here. 5 times 5 is 25. Got to bundle the 2. 5 times 3 is 15. Plus 2 is going to give me 17. And 1 times 5 is 5. Plus 1 is 6. I'm done with the 5. Then I'm done with these little one numbers that we put up there. And I'm going to use just a different color here. And since we're done in the ones place, I'm going to put our 0 down. So everything's going to be 10 times as big when we use this 1. 1 times 5 is 5. Or think about it as 10 times 5 gives 50. 1 times 3 is 3. And 1 times 1 is 1. And let's find the sum of these. 5, 7, 8, 9, 10, 11, 12. 6 plus 1 is 7, plus 3 is 10. Have the bundle. And now since we multiplied by 10 and multiplied by 10, we're actually going to be dividing by 100. And you could just divide by 10, divide by 10. And as we do that, put it on a place value chart, we know that we're getting smaller. So these numbers are going to be moving to the right 2 places. I'm going to be left with 20.25. And this here is going to be your minutes. So I'm going to write in, where did my marker go? 20.25 minutes. That would be multiplied the whole thing, and we multiplied those to get our answer. If you did it in a fraction form, you would take this and have, well, 13 and 5/10 and make 135 tenths times, well, this was going to be 3 halves and solve it. Right? It would take a little bit of extra work, right? But you could certainly do that as well. Right? If we're looking at this in a fraction form, right? Because wouldn't it be nice to do a little fraction work with it? Right? What is 25? Well, what is 25? It's really in the hundredths place. So you could write 25 100ths and your wholes 20 wholes. And these are equal. You could certainly do that as well. So there is one of our problems here, just a simple multiplying, again, using that key word of times up in the word problem. If you have any questions about that, or you solved it this way and want some additional help with it, okay, and it doesn't match, okay, send me a message. I'll gladly help you out with it. All right. And let's see, maybe we can squeeze in one more. All right. Oh, I like this one. And well, did we do number? Well, we did number 3. We could do number 4. Oh, I like this one too. Let's try this one, number 4. A clothing factory uses 1,275 and 2/10 meters of cloth a week to make shirts. How much cloth is needed to make 3 3/5 times? So what's it all about? Well, it's about making shirts. Okay, there's our gist. Let's create a sentence. How much cloth is needed? Well, we could say they need blank what? What would be our label here? May go back up here and find our label. Well, there it is. It's meters. You could label it just M. Meters of cloth. Now, our details. Well, we have our one detail. This is how much they make in 1 week, but they really need 3 3/5 times as many. Right? Wow, that's a lot. There's a keyword times. Now, if I'm going to write an expression, 1,275 2/10 times 3 3/5. Again, it doesn't really matter which one we work with here. So now I got to stop and think, how might I solve this? Do I want to put all this into a fraction? Do I want to put this all into a decimal? Right? Well, and then I got to think, wow, what's this as a decimal? Huh? Well, that'd be a great one to do. Let's do 3/5. And I know fives go really well with tens. Okay, so how might I get from 5 to 10? Multiply by 2. Now if I do the denominator multiply by 2, what do I have to multiply the numerator by? If you were saying 2 as well, you're correct. Give us 6/10. So now I am left with 3 6/10. I don't like this decimal here, so I'm going to get rid of it by multiplying it by 10. So 7, 5.2, going to multiply it by 10. And now I'm with 12,752, which is really our tenths. And we could even label that there. I don't think we did in the last problem, tenths. And we have 3 6/10. Remember, here's made an equivalent fraction. I'm going to multiply it by 10. And now I'm down to 36/10. Now we have to multiply these together. Now if you run out of room, since it's going to be a little bit big, use a scratch piece of paper on the left side of your work. I'm going to start with 6. 6 times 2 is 12. Need to bundle. Great practice from Module 2 work here. 6 times 5 is 30, plus 1 is 31. I'm going to bundle 3 of them. And 6 times 7, 42. 42 plus 3 is 45. A bundle of 4 and 5. 6 times 2 is 12, plus 4 is 16. And 6 times 1 is 6, plus 1 is 7. I am done with the 6 in the ones place. I'm also done with all these little ones here, so I'm going to cross it out. I'm going to put a 0 here because now everything's going to be 10 times as big. So 3 times 2 is 6. 3 times 5 is 15. You have to bundle. Now just make sure you be neat and organized there. And what do we say? 15. 3 times 7 is 21. Plus 1 is 22. Bundle the 2. And 3 times 2 is 6. Plus 2 more is 8. And 3 times 1 is 3. We need what do we need to do with those? If you were thinking find the sum, you're correct. So 2, 7, 10, need to bundle. 6 plus 1 is 7, 8, 9. Right, there's 15. You have to bundle the 1, and there's 4. Right, now, that's a huge number. But remember, we multiplied by 10 and multiplied it by 10. So we're really going to take this work and we're going to divide it by 100. Means our numbers are going to get smaller, so they're all moving to the right. You can put it in a place value chart if needed. Right? It's going to give 4, 5, 9, 0. And then the 7 and 2 are going down the opposite side of the place value. Again, make sure that you're being nice and neat, as I try to be on this Chromebook here. Right? And this is your answer. Okay? Please be careful to remember that you got rid of those decimal points up at the beginning, so you have to divide. So I'm going to put that in, 4590.72, or 4,590 and 72 hundredths of a meter. There you go, ladies and gentlemen. Feel free to send me a message if you need to. Good luck.